Hey everyone, we're talking today about Newton's law of cooling, how to figure out the rate of cooling, and then how long it'll take for an opossum fresh out of the oven to reach a temperature of 110 degrees. All right, so here's where we're at. We have our formula that says the temperature of any item over time is equal to the room temperature plus whatever your initial temperature is minus, again, whatever the room temperature is, times E to the rate of cooling times the time, lowercase t. Ladies and gentlemen, the first thing we want to do is we want to take a look at the given temperature of 395 degrees after 15 minutes. We're going to plug these numbers in for the original, for the time, and for this temperature after time. Guys, what's this capital T stand for? Room temperature. So what are we going to plug in there?
70.
70 here and 70 here.
Yeah.
What does this stand for?
Initial temperature.
What is the initial temperature?
425.
425. Notice, folks, basic algebra says I got to fill in for 4 out of the 5 variables. I think we can do that now. I'm going to write 395 equals, let me erase these so we don't confuse everybody, equals 70 plus the 425 minus
70.
times
E to the 15K.
15K or K times 15, however you want to look at it. All right, so what do you think I should do first, guys? Subtract the 70 across. You guys want to subtract the 70?
Yeah.
Okay, I'm fine with that. So let's subtract the 70 across. Subtract the 70 across. When we do this, we get 395 minus 70 is 325.
And you have to do it inside the
Equals, yeah, what do you say?
inside the
Yeah, couldn't I subtract these two right here and get
355.
355? Thank you. So 355. So I'm at 355 e to the 15K. Now what do you think I should do? Divide both sides by 355. All right. Hey folks, when you do this, you can leave it as a fraction because you're going to be using your calculator to do this the whole time. Let me go ahead and warm up the calculator here. All right. So I'm going to get this 325 over 355 equals e to the 15K, right?
Yeah. It's like 0.9154 or whatever.
Yeah, you're going to get you're going to decimal. It's close to 1, isn't it?
It's
All right. 0.914. So this number right here is approximately equal to 0.914. 0.915. Okay.
Yeah.
Now again, don't round it. In your work, you never want to round this,
it's not.
especially because our calculator.
It's 0.9154 and then.
Exact.
Yeah. No, not exact, not exact. No,
Round it.
like,
Okay.
No.
Wait, can we just wait until we do it?
I agree.
Okay. Here we go. So
Sammy, I'll prove it to you.
Alright, stop.
all right. So here we go. We're at this stage now. From here, folks, what should I do? Take or change this to log form, right? So what would this be in log form?
25
over 355.
equals
15K.
And then divide by 15.
Divide by 15, I get K equals the ln of this 325 over 355
Well, you should divide.
over 15, right? Now again, folks, your calculator will do all this and store that number for you, right? Now this number that you come up with will be the rate at which it's cooling down. So does anybody have this number?
It's negative 0.0059.
So K is approximately negative 0.0059, you said?
Yes.
Yeah. Okay.
Good job, guys.
Ladies and gentlemen, so why is this number negative, by the way? Because the temperature's falling, isn't it, right? Okay, so now that I know that how fast it's cooling down per minute, couldn't I use this number now to figure out how long it's going to take to get to 110 degrees?
Right.
Right? By the way, little known, I don't know if you've ever thought about the cooking industry. There are rules about how hot food has to be. I don't know if you know this, right?
About cookies?
Yeah, there are rules. Like certain foods have to be reach a temperature of like 160 degrees and things like that.
Hot Pockets. Yeah.
What's that? Because
just to cook them?
yeah, because it would be unsafe,
They could be raw or something.
Exactly, like chicken, pork, things like that. You have to make sure that the internal temperature reaches a certain temperature because if you don't, you'll get things like salmonella or
Salmonella.
I love salmonella.
Dude,
Or
it's so good.
well, I don't know, tapeworms. All right.
Maggots.
All right, let's go back. So now that I know,
Yeah.
now that I know this constant, let's go ahead and try and find this new this new time that it takes to reach 110 degrees. So what do you think I should do, guys?
100.
You should solve.
Okay, actually, let me come back in here real quick, and let me just erase all this, because we've already figured this stuff out, so we don't need this anymore. Right, so now, what will I do?
Plug 110 for
I'm going to plug 110 in for the temperature over time, then 70 in here,
Yes.
plus,
Wait, why
still
70?
425,
Wait, why 70?
because again, that's the room temperature, right? The room temperature doesn't change.
Oh, minus 70.
Minus 70 again. E to the, well, this number right here, the negative 0.0059,
559.
yada, yada, yada. And then T is the variable I'm looking for here, right?
Right.
Yeah.
Again,
Wait, I
is
don't
it-
get
is-
why you put 110.
Yeah, me neither.
Because again, doesn't it say, the actual overall question is how long will it take to get to 110 degrees? Right? Like, for example, suppose you say to yourself, hey, someone's going to burn their mouth if the temperature of this food's over 110 degrees, right?
Got it.
So you say to yourself, before I can serve this to my guests, I got to make sure that it reaches 110. Don't put it up before then. But the guests are here already. Oh, geez, what are we going to do? Because you got to let it cool down, right? So you got to, entertain them, give them cocktail, give them the horse dovers or whatever.
What the hell is a
Hors
horse dover?
d'oeuvres. Oh.
What's a horse dover?
Or it's hors d'oeuvres.
Oh no!
not
Oh.
hors
All right.
Okay.
It's I think it's a French word for like small appetizers.
d'oeuvres. Yeah.
Yeah, great. All right, ladies and gentlemen. So let's solve for T. So I would subtract the 70 across, right?
Yeah.
I get what, 40? Equals, in this again, I'm going to have 425 minus 70 is the same as 355, right?
Right.
Yeah.
E to the negative 0.0059, yada, 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 T, right? Now what do I do?
Divide by 355.
Divide by 355. So when I do this, I get 40 over 355 equals E to the negative 0.0059 T. And then,
Put it in log.
Yeah, like
what would that be in log form?
LN.
ln of,
40 over 355.
uh-huh,
Equals negative 0.059.
okay.
That's all you
Send
said.
them
And then from here, you divide by that rate,
Negative
the rate of cooling, and you divide by the negative 0.0059, yada, yada, yada. Divide by the negative 0.0059, yada, yada. You get T equals. Now, folks, again, on your okay, what we're going to do is, let me just catch up to speed here. What was it? It was ln of 325 over 355, was it?
Yeah.
Was it original?
No, 40 over
40
over
over
355.
40 divided by 355?
Yeah. Divided by. That did not work.
No. Wait, Mr. Collins.
Yeah.
I thought that you couldn't do,
Is
Like
the
rounds
number,
of
the
rate,
rate is
yeah.
unlocked.
You can, right?
So you put the answer in, like the answer button?
and then
Right, so it's this divided by that rate, right?
Yeah.
Now watch how I'm going to do this. I'm going to divide that by the original
I know.
rate, which was ln of 325.
Oh, I see.
Wasn't it 325?
Yes.
Yeah.
So
Yeah.
325 divided by, I haven't done that on my calculator, 355,
Yeah.
Well, they're
Wait,
divided
why?
by
Right.
It was divided by something else.
which was, and then
Divided by 15.
Here, you remember?
divided by 15,
Sure. To find K, so 355
Right.
355.
like that.
Yeah.
And when you hit enter now, you should get your answer of,
Move the calculator.
right? All right, and then hit enter. And we get a time of, or 370 minutes, is that what you got?
Wait, but I got.
Yeah, don't round. Okay, who got 370.90?
I got 370.0, but I did it like over the rate.
That's fine. As long, you don't want to round, folks. You got to use the calculators.
Why didn't you divide it by negative .0059?
That is. Honey, this ln of 325 divided by 355 over 15, that is that rate, isn't it? That is that negative .0059, okay? Anastasia?
So why did you put like the LN? Can you just put like the answer if you did?
You did. Again, if I was doing this originally, I would have done this math like to get that rate, and then I would have just gone in and cut and paste that
Okay,
answer.
now I got it. I got.
All right, so the final answer, the final time is this many minutes. 370 minutes? Wow, that's a long time. That's 6 hours, right?
For cookies to cool down?
Yeah, I'll pop some cookies.
Oh yeah.
All right? So 370.91, and then the units in this are minutes, right? Because it took 15 minutes to cool down that far, right?
Yeah.
Okay? We're making exponentials and logs in the real world. There's a formula that tells us the average learner how fast they can memorize a list of
Are you
words.
recording this again?
Yes, I'm.
Whoa.
Folks, it says here, the time it takes to learn a list of vocabulary words can be modeled by this equation. T equals negative 47.456 ln of 1 minus L over W, where W represents the equation, represents the number of words in the list. So this capital W is how many words are in my list. Capital L stands for the number of words learned over time, T, and T is the time in minutes. Okay? So this is how many total words are in the list. This L stands for how many words you've memorized in the list, and this T stands for how many minutes it takes to memorize those words, right? So if you had like, somebody said